So I got a really simple, approachable problem for you today. You know, it's an easy Friday, easy solution. I'm going to try to really make this video less than 5 minutes. So let's go ahead and get right into it. And hopefully this will be a 5-minute Leetcode solution. Exactly what people need with short attention spans, long attention spans. I don't know. 2946 matrix similarity after cyclic shifts. Okay, you are given a zero indexed m by n integer matrix mat and integer k. You have to cyclically right shift odd index 6 rows k times and cyclically left shift even index rows k times. So what that basically means is, you know, if it's an odd row, you're going to right shift it. So you're going to move all the elements over k times. And if it's even, you're going to move them all over left k times. Okay. Return true if the initial and final matrices are exactly the same and false otherwise. Okay, so if this cyclic idea doesn't make sense, you know, an example is probably your best bet of understanding what is going on. Okay, so we have this initial matrix. I'm going to write it in this form. Okay, so we have 1, 2, 1, 2, 5, 5, 5, 5, 5, 5, 5, and 6, 3, 6, 3. Okay. Now, this is mentioning the odd index rows, even index rows. Okay, so odd numbers are, you know, 1, 3, 5, 7, so on and so forth. Even numbers are 0, 2, 4, 6, 8, 10. Right, so maybe we should just keep track of the rows, right? So this is an even row, so it's going to get shifted to the left. And this is an odd row, should get shifted to the right. This is an even row, and it's going to get shifted to the left. Now, what does that mean shifted k equals 2 times? Well, shifting 2 times in any direction just means that, you know, you shift over, which makes sense, but then you also kind of wrap back around. Okay, so this 0 is going to shift left k times. So this element is going to shift left 2 times. So it's going to go 1 over left, but since there's nothing to the left here, it starts back over here, and then 1 over left again, and it's going to end up here. Right, so this one will shift over 2 times. And let's make this new array, and we'll put boxes on it so it's clear where things are going. So this 1 ends up here. This 2 shift overs 2 times, so shifts over 1, shifts over 1 again, right? Because it runs out of space, so it kind of restarts. It goes back to the beginning. This 1 shifts over 2 places, so it shifts 1 over, 1 over. And this 2 shifts over, 1 over, 1 over. All right, how about these 5s? Well, of course, they're all the same, so no matter how you shift them, it's going to be the same. But let's just do it for the sake of this making sense. So it shifts over 2 to the right because it's an odd index. So 1, 2. So there's a 5 here. 1, 2. There's a 5 here. 1 back around 2. So there's a 5 here. And then 1, 2. There's 5 here. Okay. 6, 3. So to the left. So 1, 2. 6 here. 1, 2. 3 here. 1, 2. Now there's a new 6 here. 1, 2, there's a new 3 here. So I think that's pretty clear about what's making sense here. And then at the end, you return if it's true if all these things are the same, right? So this one is the same as this one, right? 2, 2, 1, 1, 2, 2, 5, 5, 5, 5, you know, so on and so forth. They're all the same. Okay, now what you'll notice here for this to work is, well, in order for it to be the same after, right, we could rebuild the whole array, but maybe that's not our best bet, okay? You know, in order for it to be the same after, it needs to end up in a place where the element is the same, right? These are the same because this 1 ends up here where there was a 1 initially. Okay? And this 2 ends up here where there was a 2 initially. Okay, so instead of rebuilding the whole array, what I'm really trying to get at here, right, is if we have 1, 2, 1, 2, 5, 5, 5, 5, 6, 3, 6, 3, all that really matters is, well, if I'm going to move this 1, well, where is it going to go? Well, it's going to go in this position. And if it goes in this position, in order for it to be the same at the end, what was there initially needs to be what I'm putting there now as well, right? These have to agree. When I put this 2 somewhere, I'm going to put this 2 here, so they have to agree, right? When I put this 1 somewhere, 1, 1, 2, 2, right? 5, 5, whatever, 6, 3, 6, 3. Right? Now let's look at an example where that doesn't work so you can kind of see, you know, why this might be a problem in other cases, right? So in the case of, let's just say 1, 2, 3, or, yeah, let's just do the 1, 2. So this is 1, 2, right? K equals 1. Well, this 1 is going to move, right? And it's going to have to move 1 to the 0 would be 1 to the right. Or no, 1 to 0 is left, right? Even is left. So left, so this 1 will have to go into this spot where there was a 2. Well, it can't go somewhere where there's a 2, so this is false. So basically what we do is we just go through and we say, okay, when I put you in a new position, is that the same thing? If it's the same thing, then it could still be the identical array at the end. But if I put you in your new position and it's not the same thing as what was there before, then it's not going to be the same when I have the result. Okay, so hopefully the code makes a little more sense when I actually write it out. All right, so we're going to look at each row in range. I'm going to disconnect for range length of mat. We're going to look at each column in range length of mat. Okay, and then we say, okay, well, if the row is even, and if a row is even, that means mod 2 it equals 0. Okay, this is just a standard way of notating if something is even. If row mod 2 equals 0, okay, and what? Well, if I shift it over, right? So I'm going to be shifting over the element. So what's my new column at this place? Where I'm going to take the column, I'm going to take the mat at this row, and the place I'm going to put is where I'm going to shift it over K. But since I might wrap around, right? When you wrap around, right, I go all the way left. I don't want negatives. That's what modularization is going to allow you to do. When you mod something by a space, it keeps it within the cycle of the space, okay? So if I mod this by the length of mat 0, okay, this should be mat 0 here, right? Because I want the column length. If that's not equal to what I need it to be, which is the original value that I'm moving, right? So I'm saying the value that I'm moving, if it's not equal to the value of where I'm going to put it, then these things aren't equal and I have to return false. Okay. And then it's pretty much the same thing if it's odd. So if this is equal to 1 and I add in K and they're not equal, I return false. And if I'm able to go through the whole entire array and check all the possible shifts and they all are equal in the original place to the new place, then we return true, right? So if none of these things are false, that means everything is true, so we return true at the end. No bugs, no bugs, no bugs, no bugs, no bugs, no bugs. All right, so what's the runtime and space complexity of this? So let's say n is the length of mat, I guess, and m is the length of mat 0. So all we do is we look at all n rows, we look at all m columns for all n rows, and then we do a constant operation. So that's nm time. So that for time is O of nm. And then for space, well, we're not even creating any variables, right? We don't even create any new variables in the system. I guess we create R and C, but that's it, right? So if I had 1 million inputs, 10 million inputs, 2 inputs, 400 million inputs, 1 billion inputs, infinite inputs, I only ever create these 2 variables RC, so it's constant. Okay, O of 1. All right, guys. Hopefully that was quick enough, simple and easy problem today. Hope you have a beautiful rest of your day.